Hi everyone, welcome to my personal lecture hall, Villapando lecture hall. I'm covering Math 150, Calculus 1, Section 3.3 today. We will talk about increasing and decreasing function and then the first derivative test. First of all, I want to go over Theorem 3.5, which said that let f be a function that is continuous on the closed interval AB and differentiable on the open interval AB. If f prime of x greater than 0 for all x in open interval AB, then f is increasing. The second case, if the first derivative is less than 0, then it's decreasing. The third case is if the derivative equal to 0, then it's constant. The function is constant. Think about slope. If slope is positive, then you have an increasing function. If the slope is less than 0, then you have a decreasing function. And if the slope is equal to 0, then you have a horizontal line, a constant one. A function is strictly monotonic. It means that it's increase all the way or decrease all the way. Let's look at the example. We want to find the open interval in which the function is increasing or decreasing. F of x is equal to x squared plus 6x plus 10. This is quadratic equation and a is positive. As you look at the equation, you know it's a parabola open up, which means you're going to find the minimum is going to decrease and then increase. But let's follow the theorem. First, I'm going to take derivative of a function. Alright, I'm going to take derivative of this function. Then I'm going to have 2x plus 6. Alright, next step I'm going to do, I'm going to set it equal to 0 to find a critical point. So 2x plus 6 equal to 0. I'm going to solve for x. There are more than one way to do this, but I'm going to factor out the 2. You have 2, so now we're going to equal to 0. Then x plus 3 must equal to 0. Then my x is equal to negative 3. Alright, this is my critical point. Let's look at the number I. Negative 3 is over here. You have two regions. On the left side, you have an interval from negative infinity to negative 3. Alright? On the right hand side, you have negative infinity to positive infinity. So I'm going to pick a test point within this interval and test into my derivative function. So let's say I'm going to pick f prime of negative 4. Negative 4 is in this interval. I'm going to substitute in the derivative here. Then I have 2 times negative 4 plus 6, which is negative 8, plus 6, which is negative 2. Negative 2 is less than 0. From the theorem, this interval is decreasing. Alright? Now let's look the right hand side. I have to pick a number. You can pick any number. Pick the easy one for you. I'm picking x equal to 4. So f prime of 4, substitute in this function. I will have 2 times 4 plus 6. That is 8 plus 6, which is 14. 14 is positive, which means the interval from negative 3 to infinity is increasing. Alright? let's look at the next example. Now let's look at this function. F of x is equal to x to the cube minus 6x squared plus 15. Again, first step, I'm going to take derivative of this function. So that's my derivative of a function. Next step, I'm going to set it equal to 0. And solve for x. Now I'm going to factor out the GCF, which is 3x. So I have x minus 4 equal to 0. Alright? From here, either 3x equal to 0, which means x equal to 0, or x minus 4 equal to 0, which means x equal to 4. I have two critical numbers. Alright, let's look at the number line. Zeros over here. 4 is over here. So I have 3 regions, 1, 2, and 3. Alright, the first region, the interval is between negative infinity to 0. The second region is from 0 to 4. And the last one is from 4 to positive infinity. Alright, I'm going to pick a number within this interval for the first region. So the first one, I pick negative 1. So f prime of negative 1. Plug in here. Alright, so you're going to have 3 times negative 1 square minus 12 times negative 1. Anything square is positive. So I have 3 plus 12, which is 15. Actually, you don't have to solve it all the way. As long as you know it's positive, that's enough. Alright, since 15 is positive, this is increasing. Alright, the second interval is between 0 and 4. Let's pick 1. I pick 1. Again, substitute in the f prime of x. Then I have 3 times 1 square minus 12 times 1. Then I have 3 minus 12. Again, you can solve it or you can look at it as negative. Then this is decreasing function. Alright, and the last interval is from 4 to infinity. I pick 5. I would have 5 square minus 12 times 5. Alright, solve this. It's going to be 3 times 25 minus 60. 75 minus 60, which is 15. That is positive. All you need to do is realize positive or negative. Alright, since it's positive, is increasing. So each interval, this is increasing, decreasing, and increasing. Next, we're going to find the maximum and minimum, which require the first derivative test. Hi, let's look at Theorem 3.6, the first derivative test. I believe this is on page 181 in the book. Alright, let C be a critical number of a function f that is continuous on an open interval I containing C. If f is differentiable on the interval except possible at C, then you have 3 cases. Alright, the first case is if the f prime of x change from negative to positive at C, then F have a relative mean. Think about change from negative. So you're going to go down and then go up. Then it will be minimum. The second case is when f prime of x change from positive to negative at C, then f have relative max. Okay, change from positive is mean it's going up and then it coming down. Of course, you're gonna have relative max. The third case, if it doesn't change, so it's not neither relative min or relative max. Let's look at the example. Alright, let's go back to our first example and we're gonna apply first derivative test. You see the first interval here from negative infinity to negative 3 is decreasing, and this is your critical number. So you're gonna have something going down and then increasing, which means going up. As we say, it's gonna be a parabola, and this is the minimum point. Now, this is your critical number, all right? To get your minimum point, you have to plug in the function f of x, all right? So f of x, you plug it in here, all right? So I'm gonna do f of negative 3. All right, f of negative 3. Let me change the color because of the red. All right, so f of negative 3. Make sure you go back to the original function, not the derivative one. So you're going to have negative 3 square plus 6 times negative 3 plus 10. All right, if you do this, you're going to have 9 minus 18 plus 10, which is 1. So you're going to have a minimum point, right? So your minimum point or relative mean would be negative 3 1. So it's going to be this minimum point, negative 3 1. All right. Now let's look at the next example. We have 3 interval, right? Of course, this is degree 3. Okay, the first one is increasing and then decreasing and then increasing. So let's look at this. It's increasing and then decreasing and then increasing. That's how the graph should look like. Alright, so this is your maximum, relative max. Alright, so relative max, again you plug in 0 for the original function. So f of 0, you're gonna have 0 minus 0 plus 15. So your relative max would be 0, 15. Relative max. Now this one will be your relative mean. Alright? Now your relative mean, you will plug in 4 for the f of x function. And I did solve this. I got negative 7. So this point will be 4 and negative 7. Alright? Let's look at the next example. Hi, let's look at this example. F of x is equal to 1/2 x minus psi of x in the interval 0 to 2 pi. So first thing we're going to do, we're going to take derivative. Alright? Derivative of 1/2 x is 1/2. Derivative of psi of x is cosine of x. Alright? Second step, we're going to set it equal to 0 and solve for x. So I'm going to do 1/2 minus cosine of x equal to 0. Alright, then I'm going to have cosine of x equal to 1/2. Alright, Now you have to go back to your trick and figure out what x that make cosine of that x equal to 1/2. By solving this, x would be pi over 3 and 5 pi over 3. And this is your critical point. Alright, let's look at the graph. Now my interval is 0 to 2 pi. Alright, 0 is over here. Pi over 3 is over here. 5 pi over 3. And then 2 pi. Okay, that's my interval. So you have one region here, second region is over here, and then the third region. Alright, so look at the first interval here. This is the interval between 0 and pi over 3. We have to pick something in between this, alright, and plug it in the derivative function. I pick pi over 4, so f prime of pi over 4. So we're gonna put in here, alright, so that is 1/2 minus cosine of pi over 4. Alright, 1/2 is 1/2. Cosine pi over 4 is square root of 2 over 2. Obviously this is less than 0, so this is decreasing. The next interval between 5 pi over 4 to 5 pi over 3, I mean 5 pi over 3 to 5 pi over 3. So I pick pi. Again, plug in this function. So I have 1/2 minus cosine of pi. 1/2 is 1/2. Cosine of pi is -1. Obviously this is positive, so this is increasing. Alright, last interval, 5 pi over 3 to 2 pi. I pick 7 pi over 4. So plug in this function again. I have 1/2 minus cosine of 7 pi over 4. Then I have 1/2 minus square root of 2 over 2, which is negative. So this is decreasing. So it changed from decreasing to increasing. Decreasing to increasing. So this is relative max. Alright, relative max. Wait a second, relative mean. Because it's decreasing and increasing. Yes, relative mean. So at x equal to pi over 3. Alright, now look at this one is increasing and then decreasing. So this is relative max right here. At x equal to 5 pi over 3. Alright, we just finished 3.3. You ready to do your homework? Please make sure to do your homework before we go to the next section. Alright, bye.